The second technique is Cartesian feedback technique. So it is similar to negative feedback. You can see here, I give input signal, I amplify it, and I multiply by LO power amplifier. And I take the output, multiply by the same LO with the phase shift of theta, filter it, and again give it as feedback signal to the op amp. So it is a simple example. A transmitter consists of only one up conversion mixer and PA. Whereas in the feedback path, I have the replica of my transmitter. It will have one more mixer in the thing. The total phase shift is going to be very significant. The phase shift theta is added so that it ensures stability. Ideally, theta 0 work, but in case if the circuit develops a phase shift, by introducing this phase shift of theta, I can cancel out that phase shift. So this theta is going to be for tunability of your circuit. Next, this is for single channel. If I'm going to go for I and Q now, the same will be repeating twice. One set for I and one set for Q. The same will be repeating twice for in phase and quadrature phase components. Okay, so that is the Cartesian feedback technique, and it faces severe issue. The choice of LO is straightforward, and if that LO is going to vary with frequency or phase, that is going to be an issue because the performance is dependent on local oscillator only here. Okay, and the local oscillator is going to be a crucial component in deciding the performance of this type of power amplifier.